Good morning from the other side of the globe to those of you in California and in the US. My name is Sean O'Mara. I'm from Marantis, Field CTO, and today I'm going to be talking a little bit more about what's holding us back from true hybrid multi-cloud applications. We have a specific interest in dealing with multi-cloud, and we've been working with a lot of customers who are attempting this multi-cloud journey. So I'm going to talk a bit about some of our learnings from that experience, a few ideas behind the challenges we're seeing just talking about using the correct terminology, correct patterns, why multi-cloud makes a lot of sense for us. And of course, let's cover a couple of multi-cloud use cases. We'll talk more deeply about some of the challenges we're seeing, how we can deal with some of those challenges, and I'll sum up with what does it really need to make this work? And I'll offer some of my own personal opinions on the gaps and how we can start to fill them as a community. So let me kick off straight away. If we look at the community, if we look at everything that's going on, there are millions of different terms being used and different bodies who are deciding their own terms. But for simplicity and for purposes of today's conversation, I just try to simplify things for the discussion. So we all know what a public cloud is. And for the purposes here, we're talking about a single public cloud provider offering the range of services. And an example of this would be an AWS or an Azure or a Google. Anybody who's offering infrastructure as a service or platform as a service services from a public cloud that you can subscribe to. Now, the next two terms which we see bandied about a lot is this line between hybrid cloud or multi-cloud. What is the difference ultimately? To me, they're basically the same thing. The difference being that hybrid cloud generally refers to a combination of public, private, and some kind of on-premise cloud solution where you're spreading workloads across those two or three different platform types. Whereas multi-cloud is just two or more cloud providers. And I tend to go, well, does that make a difference whether it's hybrid or multi if I also have private cloud solutions within that? So for today's conversation, hybrid, multi-cloud, we'll use them interchangeably. Ultimately, I'm talking about multi-cloud, the challenges of dealing with multi-cloud, and how we can move forward. So also for the purpose of the conversation, I just wanted to lay out a couple of very, very high level application patterns that we need to be aware of when we're talking about multi-cloud. And this is what we're seeing in customers. And just for the more technical out there, don't shoot me. I realize that these are just illustrative diagrams. They're not actual applications. You would probably not do very well with using these as your actual applications. The first point that I want to raise here, sorry about that. The first point I want to raise here is we're seeing two core application patterns. One, where people are deploying to the multi-cloud, deploying distinct components of an application stack to a different cloud provider. So I know it'd be crazy to have the load balancer in a different cloud to the web services, but use that as an example. We have our web services in one cloud, potentially close to our consumers, and our application services maybe in a public or a private cloud service, when there's lower traffic between them. The point being is we don't have any sort of network connectivity between these two cloud providers other than the internet. There isn't any linked capabilities within the Kubernetes or within the container engine. So let's align things that way. Whereas the second option, which is the stretched option, is where we start seeing much more complex multi-cloud solutions, where we start having direct network connectivity between these multi-cloud components. Where, as an example, we have web services that are on the same networks within the same Kubernetes infrastructure, where those pod networks are stretched across the multi-cloud. And this is a much more complex method to orchestrate, obviously, but it can offer a lot of advantages and simplicity from an app design perspective. So if we move on, my slides will work with me. So if we look at why multi-cloud makes sense for any organization, I'm going to spend a bit of time on the slide unpacking each of these, but the first and foremost one is risk management. We talking to a lot of customers across the world, and I talk specifically here in Europe, we're seeing a lot of customers who are standing up and going, we cannot use a single cloud provider. We can't potentially even be reliant fully on an American-only cloud provider because there are all sorts of privacy challenges and privacy issues. We've seen significant failures in public cloud providers over the last year. So what can we do about that? Well, obvious multi-cloud deployment helps us alleviate that risk by giving us the ability to easily scale across these clouds. Very closely related to that risk of failure and risk of legislation is regulation. A core challenge we see is privacy regulation and data sovereignty regulation, especially here in Europe. The US has similar rules, but where do I store my data, that it is contained within the data sovereignty rules, that it applies the specific data privacy rules for that region. And as an example, with the end of Privacy Shield last year, we're not supposed to store European data on American-based servers. This all relates heavily, once again, to location, but here I'm talking about location not just from a data privacy perspective and a regulation perspective. I'm also talking about location from the perspective of latency, cost management, and access to specific services. The world is moving rapidly forward towards edge and accepting more capabilities around edge. The reason for that is move the workload closer to the user, reduce the latency. The cost of storage. I have different types of things I need to store. Sometimes storing in cloud is very, very expensive. I may want to store that locally. I may have a better solution to do that. Or I might get a better deal somewhere else. So if I can pick my location where I both run my workload as well as store my data, it's a great deal of value to me, both in cost saving, but also in security of that information, and securing that from a risk perspective. That leads to the discussion of price and efficiency, of course. Being able to leverage multiple different public cloud providers, I'm not locked in. I can also start to pick the cloud provider that has the best service for my needs. If, let's use the example, Azure has a better AI service and Google has a better analytics service, I can start to pick which of those I prefer, but still run my own applications and workloads effectively across those environments. So that's an efficiency, but price, we start to talk about leverage. We start to talk about being locked in. And if I get locked into a single cloud provider, I no longer have any leverage over them from the perspective of competition. So I'm stuck there. And if I go into a single public cloud provider and it's very, very hard for me to move out without having a proper multi-cloud solution, I'm stuck. And they can put up the price. And there's not much I can do about that because the cost of moving out is probably a lot more than just staying and living with that. So, a couple of use case and examples, just very, very brief, high-level ideas, which we've actually seen people starting to implement in the usage of multi-cloud. So the very first of those, and I've just mentioned it, is cost optimization. By moving the workload to the most appropriate place for me, a good example is big data storage. I may wish to do my big data storage more cheaply on existing data center hardware that I have inside my company. But the web workloads, which are much more dynamic and they can grow and shrink, I'm going to run out in public cloud. That immediately is a multi-cloud use case. I'm running some workload on-prem or in my private cloud, some using web services to run them close to where my users are. So I potentially could be using different services in different regions of the world. And I'm doing that primarily to reduce my overall cost and be able to manage and have a better understanding of my cost, and to use the burstability and things of public clouds. It also aligns to this preventing of lock-in idea, where I can start to run components wherever is cheapest to run them at that time. And as we know, there's more and more options for that coming up in the public cloud world. Regionality, putting your workloads where they need to be. And I spoke about edge, and edge is a big driver of this. We're seeing more and more edge use cases. We're seeing more and more capabilities that need that faster, more local processing. A great example is your backdrop in your Zoom session. If that's having to be processed and in a server that's extremely far away from you and is highly latent, it's going to make your session terrible. We've been spending our lives for the last year in Zoom sessions. Anything that makes them better, that's what we want. And then the other part of regionality, of course, is the governance component. And I've spoken about data sovereignty. Disaster mitigation is a big one. And we've been talking to a lot of our customers who have gone all in on public cloud, have either suffered from failures or have governance reasons within their business to have that backup somewhere. And that backup, just the way the rules are structured, has to be in a different provider. It's pretty hard to do that across different providers. Within the same provider, you can probably leverage a lot of their systems, cloud providers. But when you have to do that across multiple cloud providers, it's a fairly complex. We need to put the right tools in place and the right process in place. And the whole multi-cloud model of application deployment definitely helps us handle that. And then the last use case, which we're seeing quite a bit of, is the scaling or bursting use case. And the primary one here is scaling and bursting when we're talking about seasonal expansion of workloads. Retailers during Black Friday or the Christmas season, when they need more web front ends, they need more capability to handle the load, which would be crazy for them to provision for the entire year where they wouldn't be using it. And that gives us that flexibility and that cost-effective resource management. We're also seeing a lot of enterprises who have invested heavily in on-premise solutions that work well for them. That investment is maturing. They're happy with it, but they need that little extra capacity, and it doesn't make sense to build their local capacity. They can start to leverage that cloud capacity. And that's the use cases we're typically seeing and that people are implementing these days. Of course, it's never going to all just be roses. It's not easy to deploy a proper multi-cloud solution. And before I get to the hows, I'll kind of take a step back and look at the challenges. A real multi-cloud solution has a higher initial effort for a number of reasons. It takes a lot of planning. We've got to take into account that we're dealing with different providers. We're dealing with different systems, different APIs, different costing models, different levels of complexity. We're dealing with different skill levels in the organization. So we need to think with more detail up front. We need to take that into account when we're doing our planning. And we've got to do the work before trying to go out there rather than trying to hack it in afterwards, which is obviously just going to create pain. Complexity is something we have to be aware of, and we have to find ways to reduce that complexity. That complexity comes in needing specific tools for data replication across dissimilar systems. It comes in having to manage all of these different, whether it's GCP, EC2, or an EKS and an AKS, what is it that I need to manage, and how do I get some level of consistency across all of those? How do I build in that management layer to really simplify this experience? Because if it's too hard for the developers, they're not going to use it, and you're going to lose your multi-cloud value. The next one is obviously networking and dealing with all the latency challenges. It's cool that we can stretch a cluster across two clouds, But what happens when the latency between the two clouds starts to shoot up because an internet connection is overloaded? That becomes a problem because you're going to get weird performance in your applications. We need the right tools and the right systems in place to handle and manage that communication effectively, localizing the data, but still providing that correct cross-site communication. And then also, I'm suddenly stretching across a very broad range of systems. How do I abstract all the networking complexity, different IP address ranges, whether it's IPv4, IPv6, whether it's different security models for egress and ingress? We need to think about that and plan for that. And then the big one, and I mentioned this a little bit earlier, but it's all about the add-on service usage. And what I'm talking about here is all those wonderful extra services provided by these public cloud providers. Now they're giving us databases, and they're giving us analytics tools and extra security tools. And of course, every cloud has a different set of tools, a different way of working with those tools. If I build applications that are reliant on something that Amazon offers versus something that is my on-prem database, it's not exactly portable, and it's not exactly easy to move it around if I'm suddenly tied into one of those services. So you have to examine the use of those add-on services very, very carefully and think about the rules you're putting in place to guide your developers to make the right decisions. Notice I say guide your developers, not dictate to your developers, because that also is very rarely successful. So how do we make this all work? So the first thing is consistency is a critical component. We need a consistent platform across all of these environments. We need to have the operational automation set up correctly so that I have consistent security, consistent policies, consistent identity management across all of these systems. And the big one is my applications must be deployed via CI/CD solutions, no manual deployments. In fact, no way to do a manual deployment is probably a really good idea. We have to understand, and Kubernetes is a good example here, it's more than just a container orchestration system. There are many different layers that we have to take into account, and I mentioned them: identity, RBAC, service mesh capabilities on top of that. How am I linking all these systems together? We have to take into account that the container orchestration layer and the container layer is just a small part of the overall solution. We need to think about how we orchestrate all those extra capabilities on top of that. I come back to consistency when I say that, in a consistent way. Centralized control, and this is going to probably cause some unhappiness with some people. Centralized control is important, but understanding that we want to build that centralized control using a federated model. We want a central way of pushing policy, of assigning RBAC rules, of assigning identity management, of deploying applications, but it needs to be resilient and be able to use multiple different systems underneath that and give us the flexibility to choose how we use them. Ease of use should probably have been at the top of the list. All of this is cool, but if it's so hard and so complex for me to deploy applications into this environment, as a developer, I'm never going to bother, because I'm going to look for the shortest path to getting my applications up and running, and that's probably going to be directly to a single cloud provider. So we need to make this easy. It needs to be simple. It needs to be really abstract the complexity from the people who don't need to be worried about that complexity. At the same time, we have to support operators in building the solutions and the tools that they need to properly support applications in production. Freedom of choice is an interesting one in any competitive environment. We need to provide that freedom so that you can select the provider and the tools that are necessary at all layers of the stack. So both underneath, what cloud am I choosing, but as well as what CI/CD tool do I choose as a developer? What security tools are most appropriate for the type of application? And then the last bullet that I'll point out here is obviously centralized monitoring goes with centralized control. If I don't have a view of all of this, I'm going to get lost. So in summary, I see my time is running down here, but in summary, what we're talking about for multi-cloud, we need consistency and we need connectivity. And the building blocks of all of this run, firstly, we need a clear multi-cloud management tool, something that can stretch across all of these clouds, provide us the correct layer of abstraction so we don't have to write applications to deal with all the different APIs, don't have to deal with all of that in our CI/CD. We need an effective service mesh solution to handle all that networking. We have to have effective security and consistent security across all these systems, ideally from this multi-cloud management tool. So we've got that single pane of glass for everything. Lifecycle management of all these different components needs to be integrated. Having a lifecycle management that's going to completely on its own handle an operating system upgrade without taking into account the workload on top of that is going to be a nightmare. You're never going to end up with upgrades. We have to be able to effectively update components with some awareness of what applications are doing, or at least some feedback into the application orchestrators, so we can do things like coordinating and draining. A usable CI/CD I've covered. The CI/CD solution today, some will handle multi-cloud, but not really very well. So if we don't have to have them address the multi-cloud and we can address a multi-cloud management API, all the better. Once again, simplicity. Freedom of choice I've spoken about. We want that freedom of choice. It's the whole driver. And I think what's important is, we have to have the right partners. There are a lot of very smart eggheads out there who we can leverage to do things in the right way, smart tools, smart partners, so that we can layer up an effective solution. So, in summary, what are you doing? We would love to hear from you, how your multi-cloud journey is going. Have you planned anything from a multi-cloud perspective? Are you doing this today? What has been your experience? What challenges have you come across? Where have you done this? What have you learned? We'd love to learn with you. We'd love to share our learnings with you. We're building tools to do this. We're really focused on this as part of the future. We'd love to hear how we can help you, what we can do to make this easier. Please feel free to reach out to me. As I said, I'm from Marantis. A lot more information on our website, a lot more information on Con's website. I'd love to hear me moving forward here. And I'm within my time. Thank you very much.